Good morning, everyone. Today is January 5th, 2019, and this is the John Chappell Natural Philosophy Society Science Chat. I am your host, Franklin Hu. So this week, it's more or less an open discussion time. So if you've got any burning questions you want answered by the group, let me know. But are there any questions out there? If not, the topic of discussion will be about a letter I received, actually a very large letter. So it's surprising that I received a letter this big from somebody. And it's written in pen and paper, so it's quite impressive. So, and it's always interesting to get feedback from other people. So, if you too would like to contact me, send email, and maybe you'll find your stuff on Science Chat someday. But in any case, so I've got this very long letter from John Roach. It's like 20 pages. And he's talking about things about gravity, about the how the universe is formed, and all kinds of stuff like that. So I'm just gonna describe what he's talking about. Now, his stuff, let's see here, let me share. He's published quite a few papers over the years, and you can find them on Vixera. So all you have to do is search for, so Vixera, vixra.org, and search under author and John Roach. So let me go ahead and put that in the chat box here. So if you're interested in learning more about what John has to say, you can check that out. Okay, so let's get back to sharing my screen here. So, and but let's get on to his letter here. So, he says he's got stuff in Vixera, and I just showed you that. And let's see here, where is his? We've got this letter, we've got that letter. I think he actually sent me like 3 letters, but they kept on bouncing until he finally got the right address. So he wrote me this letter, and I wrote him a response. So he starts out by saying that his gravity model is a combination of James Carter's gravity and with an assist from my gravity. So my gravity is an electrostatic gravity, and that's just saying that the Earth is a positively charged ball because electrons are easily lost off of any large object, and that slight imbalance in charges causes a very large positive field to develop on the Earth's surface, which causes all neutral matter to be attracted to it by basically static cling. So he kind of calls that the static cling model of gravity. Now, James Carter is a dissident scientist that's local to my neighborhood here in Seattle. And so he is published several books, and his main thing is about the atomic structure. So he bases a lot of his stuff around these torus rings. And James Carter's ideas about gravity is that the Earth is just rapidly expanding. So it's like if the surface of the Earth were accelerating outward at 9.8 meters per second, then we would feel the force of inertia pushing us down, and that's basically what they would consider gravity. So I almost consider that the exploding Earth theory, because it would have to be accelerating at 9.8 meters per second on the surface of the Earth. So my comment about that is that if you look at how gravity can be measured, you can actually measure it on very, very small masses. And this is called like the Cavendish experiment, where they basically have two like lead balls or something like that near each other. And you can actually measure the force of gravity between these two relatively small objects that are on the Earth. Now, if this expansionist theory of gravity is true, then logically I cannot see why two objects just sitting on the surface of the Earth would possibly spontaneously come together. Because if everything is expanding, the space between the small objects is expanding, the surface of the Earth is expanding, the objects themselves is expanding, I would think they would just all expand, be completely oblivious of each other, and you would expect that there would be no reason why any two objects sitting on the planet Earth would ever just spontaneously come together. But that's what we observed. And when you do that, there is definitely a torque between these suspended objects that causes them to come together, and we can precisely measure that force, and that force appears to be the same of the same magnitude that we call gravity. So that's kind of one of the objections to that kind of expansionist gravity. And I think there might be others, but I think that would be fairly conclusive. So, but on the other hand, if gravity is just some kind of electrostatic effect, I mean, clearly we know that if I charged up two balls, that they are going to exert a force between them, and size really wouldn't make any difference in that case. The only thing that would matter is the charge. So the gravity in, say, the Cavendish case can be explained as basically an electrostatic effect. And one of the things I would have predicted is that if you could really, really remove all the charge off of these two objects that are in the Cavendish experiment, you would probably find out that they don't attract at all. But it's very, very difficult to remove charges down to 10 to the 37, which is the extent of the imbalance, if it exists. So, but somehow John has tried to put these two things together, but I'm not quite sure why you would need, say, two gravity theories. He did say something about satellites would be under, say, the electrostatic gravity theory, and then the regular gravity that keeps us on the Earth is James Carter's gravity. Perhaps that might be, some of his ways around, explaining, say, the Cavendish experiment, that wherever the gravity can't be explained by expanding Earth theories, that he can always resort back to an electrostatic type gravity, since that tends to cause everything to stick. But if an electrostatic gravity can explain everything, then why would we need to have the expanding Earth theory? Which now the other basic problem with that theory is that you have to explain why everything is expanding so rapidly all the time. And I don't think there is any such explanation. So between a theory which tries to postulate something which cannot be explained versus something we already observe, I would think that something that's already observed would be fine. Okay, so I'm going to stop here. So can you guys hear me, or can you guys, so far no one has spoken.
Yeah, we can hear you.
Okay, good. So did you have any comments about, either James Carter's version of gravity or my version or what? So Mitch, go ahead. You raised your flag.
Thanks, Franklin. Yeah, I think I've heard this before, and at first it kind of made sense, because if we're accelerating up at a certain speed, it would account for the gravity here on Earth. But I'm like you. I don't see why you would need another explanation for objects that are in orbit, and I don't see why there would need to be two separate ones, especially since they've done a lot of tests. And the one kind of gravity that keeps us on Earth, I think Newton even did this, works out mathematically to the same gravity that keeps the satellites in place. So I don't think they're two distinct types of gravity. I think they're the same type, which makes me even put more doubt on this type of gravity, the accelerating Earth type of gravity.
Yeah, those are good points. That was the big thing with Newton, is that he discovered that the gravity of the apple falling with the same gravity as keeping the moon in place. So we think the gravity force is of one nature. You have any other comments out there, as far as, because this is kind of a geometric, and people have written entire books on this particular theory, that everything is expanding outward. So he goes on and he has something called plasma ether physics. So let me go and share that. I think I have it.
What books are you talking about, Franklin? Why don't you let us know?
Well, I haven't talked about any books except for James Carter's book. If you contact James Carter, he'll happily send you. For example, he sent me.
What's your reference for this theory that you're talking about?
Well, the reference is I'm getting this letter from John Roach. So he wrote me this very long letter. So that is the reference I have, and I'm taking you to Vixra, where he has his papers. So that would be the other reference. So like many distant scientists,
whose paper are you talking about?
John Roach's. For example, I'm sure.
Well, but is this John Roach's theory or somebody else's theory?
This would be John Roach's theory.
I thought we were talking about Carter.
Well, John is talking about James Carter. So he likes his stuff. So some of his stuff includes John.
Does he cite any place in his book? There are two books, as far as I know, by Carter.
Mm-hmm.
Does he cite where in these books this is discussed?
Say his gravity theory. I mean, in this one, I'm sure it's this small version here, which is kind of a summary of his work. Or you can go on the website, and you can see his stuff here.
Well,
like here, page
why
12.
isn't John Roach here to defend this? I mean, to me, you know, it's easy to criticize somebody's theory that is unfamiliar when he's not around to defend it.
That's right. So, but for lack of having any other topics, he just sent me this big letter. So I thought it might be a good topic of discussion. Now, I have my own opinions, and that's why I want you guys to chime in on your opinions on what he's trying to say here. And I'm just trying to generally explain what he's trying to say here from a third-party standpoint. I actually think it's more interesting when you hear someone talk about your theory rather than you trying to explain it, because you never really, because you have so many biases. But like I said, for today's topics, I mean, he's bringing out a number of different topics which could be controversial. So this is not an exposition of John Roach's theory or James Carter theory or my theory. We're just throwing out topics that he's got here, and I'm providing my comments. And if someday John wants to come on our science chat, or if anyone wants to go and explain their own theory, we're always open for people to do that. So, but in any case, getting back to what John is saying here in his letter here is that one of his main things is that he believes that the ether is the ever-present plasma, which be the solar wind. So I think to the extent that there's a solar wind and there's a plasma, there's absolutely no question about that. But as to whether it makes up the ether, I would have questions about whether that would be true, because it's pretty clear what the plasma is made out of. You know, it's made out of electrons and protons and various other cosmic rays. So mainstream certainly knows that is what is out there and what it's made out of. But does it make up the medium that we would consider an ether? Now, for me, that would mean the ether is what allows, say, the electromagnetic wave to travel through. There's always a question of if the electromagnetic wave is a wave, then what's it waving in? So that thing might be the ether. So is it waving in the plasma? And I would say that we are probably quite capable of creating space which has no plasma in it. And that space can still clearly transmit radio waves. So I would have to say that all of that tangible matter that makes up the plasma is still not the ether. And but he does go on and say that that the disturbances in this ether are going to be what James Carter refers to as the circulon. So in James Carter's theories, he bases pretty much everything on the circulon, which is a torus, which is like a smoke ring. And the claim here is that matter that we can see baryonic seems to be a standing wave in the plasma ether. The standing wave is formed by two opposing waves which interact with each other constructively and not constructively. So that's probably one of the main things he's saying here, is that basically it's this whole idea that matter is a wave. Now, personally, I have a very, very large problems with this whole idea of a torus representing anything in the subatomic realm. And that's just always been, say, this is my opinion, that, say, a smoke ring is quite possibly one of the most complicated fluid dynamic structures you can possibly ever think of. And they're not particularly stable, and if you crash them into each other, they tear each other apart. But yet, John and James here are based their entire theory on the existence of these things. So I just don't feel that that's very plausible, that everything should be based around that. So, Michael, you got a comment?
Well, the plasma, as officially viewed in physics, is that it's a quantum phenomenon. It's not an ether. But my ether model, I have my own ether model, as I presented before. You had originally, the first thing that happened was a universal oscillation of points, and then that transitioned to a universal vibration, and the elemental units were the points of these vibrations, were the basic building blocks of everything from then on. And you can make a very good model of quantum entanglement with that kind of a model, because the quantum units and everything else would be built up of these vibrating elemental units, which vibrate linearly and would make a good model for quantum entanglement. But anyway, to go to gravity, the way this works out is that you have an elemental ether unit continuum from everywhere, from inside the body, two solid bodies, and in the space between them. But there's a very sharp drop-off in the magnetic energy and the etheric forces aligning and entraining and linking up between inside the bodies and out, and the space between the bodies. But it would not completely disappear. There would still be some magnetic energy in that. You could call it an auric zone between the two solid bodies. And so you would have an increase in the magnetic alignment and entrainment of the ether forces, forming larger etheroidal and even quantum units. And the two bodies would feel this in between them, in the space in between them, and it wouldn't form a solid space. I mean, there's still a space there, but you have the increase in quantum forces in that space, and the two bodies feeling that they can't form a solid body in between themselves, but they do feel it, and so that's why, we see an attraction, and that's basically my model. It's not, I don't have all the details. You'd probably have to be an ether technologist to know the exact description of it, but that's the general idea of it.
Well, but fundamentally, your theory starts out with this ether particle, which you say is formed out of this fundamental vibration. Is that right?
Well, originally it was an oscillation, and then it transitioned to a vibration via the neighboring pairs of oscillating pairs formed yin-yang, and then the yin-yang had to reversibly revert to singletons, and that broke the symmetry of space, and that converted everything to a vibration, to a directional vibration, and then the vibrational units interact with each other by the outward vibrations contacting, but there would still have to be some empty space between them in order for oscillations and then vibrations to occur. So it's not a complete solid thing. It's an ether with spaces in between, little tiny spaces in between the units. But the units are not that far apart because they can still interact as their outward vibrations come in contact. And so that's my basic model. But it's especially good for explaining quantum entanglement because you have the ether matrix is made up of these units, and the same exact units are also the building blocks of the quantum units. And so the two quantum units maintain a perfect connection between them, even when they're separated. And in fact, I don't know of any other model that makes sense other than this model for myself for quantum entanglement. But as far
how
as
can I explain to you that quantum entanglement doesn't actually involve any communication between the particles?
Well,
It's not like
that's the Franklin-Hughes theory, but if you go to the consensus view of quantum entanglement, there does seem to be a general agreement that there is a real phenomenon going on here, and that there is a perfect connection between the two units after they've been separated. It's
Well,
not
I
just a
suppose,
left glove and a right glove thing.
I suppose that would be a bone of contention as to how that's interpreted. But I think even mainstream recognizes that there's no actual communication happening between the two particles. But it seems very much in the popular interpretation that that's what they're kind of implying, that somehow you could take particle A and turn it from like state, if it had like two states, 0 and a 1, and turn it from 0 to 1, that the other particle a billion miles away would turn to 1. But I don't think they've ever shown that ever happening, that is just completely wrong. That's just,
you can't show it because it's etheric. You can't detect the ether. That's the problem. I mean, it's
no, that's not the problem. The problem is that quantum entanglement does not involve any communication.
Well, if you just go at it from the quantum perspective, from observing quantum observations, then you're ruling out an ether to start with. You're not even giving it a chance.
No, I don't think so. I don't think quantum entanglement has anything to do with the ether. Quantum entanglement could happen without an ether because it's a particle phenomenon.
Yes, but my point is that the quantum units are made of the same elemental ether units. In other words, the ether units, when they formed, they were the basis for everything from then on. Everything, you, me, the quantum units, everything is made up of them. And if you take gravity, the solid bodies and the space between the bodies also are an elemental ether unit continuum there.
Well, that's in common with everybody's ether theory. Everybody's ether theory says that. There's no controversy about the space-filling ether concept. The only controversy would be just what on earth is this ether particle? So lots of people say different things. James Carter would say it's a circulon. I would say it's positrons, electrons. You would say it's your fundamental. Did you give it a name or anything?
Well, an ether would be universal. It would be everywhere. It would have to.
Yeah, everybody agrees about that. There's no controversy about that. But for your ether particle, did you give it a name so we can talk about it?
Well, the only a possible substrate for a first causal oscillation would have been, the only possible substrate would have been space itself. And if the oscillations transition to a vibration, that would mean that the ether is massless.
So, you're giving an explanation. I'm just asking you, is there a name so we can put a handle on it so that we know, so I can call it. Otherwise...
Well, you can call it a matrix composed of units, composed of vibrating units.
So let's call it vibrating units. That's your ether particle. It's a vibrating unit. How about that? Can we agree on that?
Also form a matrix, which, if you want to have a substitute for the word plasma, I would say matrix, universal matrix.
But I don't think the plasma is the matrix. Do you agree or disagree?
I'm trying to say I don't like the word plasma either. Plasma is a question of ionized quantum forces involved, and it's different from the ether. People borrow the word plasma and transfer it to the ether, but physics uses plasma in the sense of quantum forces. It's two different things.
I don't even think that physics uses plasma in a quantum form. You can easily form a plasma by taking a gas, stripping off the electrons, and you have a plasma. That's what a plasma is. So it has nothing to do with quantum mechanics, I don't think. They say, Bill, you've raised your flag. What do you have to say about this?
Well, the experiments of Arthur Compton and Winston Bostick showed that the background of the universe is the electromagnetic field, and it has tensile strength, and it doesn't consist of particles. It's a field that's continuous. So
and how do you know it doesn't consist of particles? That's the question.
Because we make particles out of the field. We make what are called solitons, or certain types of standing waves with long lifetime, out of the field. And the concept
Well,
of
I don't
charge,
think you've seen that, have you?
the concept of charge and particles is an approximation, but it's not really valid.
So in my reading of your materials, you've created solitons out of plasmas.
Well,
And-
it's out of the field. It's out of the electromagnetic field. With
Yeah,
no
but that's a
particles
theoretical
involved.
part.
No particles involved at all. So for instance, the toroidal ring is continuous. It doesn't have, if it had particles in it, it would be subdividable, but it's not. There's no
Yeah,
particles.
but that's logically inconsistent, because if you're like James Carter and you demonstrate these toroidal rings using smoke rings, those are obviously made out of particles. There's the only way that it can flow is if it's made out of particles. So logically, to say that it doesn't contain particles is a complete contradiction, isn't it?
No, because you're looking at forces on different levels. For instance, the electromagnetic force is the strongest force we know of. And when you look at smoke rings, you're looking at the forces between atoms in a gas, in air, for instance. So you're not looking at the fundamental force, you're looking at secondary, tertiary level forces. And those do have dependence on particles that have been made from the primary field. So your scale has a lot to do with it. And you don't have smoke rings on the scale of galaxies and that sort of thing, but you do have the electric field on that scale. And you see it, and you can observe it and that sort of thing. So yeah, it has to do with scale. And if you can't just apply the same arguments to all different scales, because
I think at the scale of subatomic particles, you've got to decide whether the thing that you are describing even looks or acts like a smoke ring. I mean, it might not. John Bergman's ring theory of the electron, I don't think has anything in common with the common smoke ring other than it's a ring. Would you agree with that statement?
Just go back to the most ancient natural philosophers. What does the word atom mean? Uncuttable. Well, what is uncuttable about a smoke ring? Nothing. What is uncuttable?
It's totally cuttable.
Huh?
Smoke ring is totally cuttable.
That's right. It doesn't apply. So it's not the same phenomena as like the ring that Winston Bostick and Arthur Compton discovered experimentally, just using the electromagnetic field. And but the ancient philosophers, even before the Greeks and the Indian Jains and those type of people, they knew that whatever was the fundamental building block, you would say, of the universe had to be uncuttable. And so that can't refer to particles. Particles are cuttable. Every elementary particle can be cut into parts.
I don't think an electron can be cut, can it?
Yes, it can be cut into 3 parts.
I've never seen that experimentally. Certainly you have not.
Yes, we have. And
no, I think that that's certainly something that mainstream definitely doesn't recognize.
What you do is you do low energy electron scattering, and you can see the 3 subparticles that make up the electron.
Well, and I have not seen anything.
I did that at the College of William and Mary in Williamsburg, Virginia. It's a published thing, and it's known in the scientific community, but it's not politically acceptable. See, politics plays an awful big role in science, unfortunately. Because
I suppose that could be. It's just I may not have never heard of that.
Yeah, but see,
everything the politically correct mainstream scientists would say is that they've never been able to find any structure in the electron at all.
But that's not true, because low energy scattering, less than 1 electron volt, shows the structure of the electron. But do you see it? I mean, do they put it in textbooks? No, because it doesn't agree with their politically correct theories. So whoever's in charge of the silo for this time decides what will be acceptable and what will not be acceptable.
If you go to the ether theory, it's the electron is a subquantum unit, and it would be built up of individual ether units, building up to etheroidal and then on up to quantum units. So it would be consistent with my model that the electron would be built of smaller energy units, going down to all the way down to the elemental ether unit, which is the fundamental elemental unit. And of course, physics doesn't recognize ether units as the elemental unit. They consider electrons to be an elemental unit, but I think they're wrong.
Yeah,
This is
problem is that we have this theory of quantum mechanics, which the politically correct theorists like, and but quantum mechanics has been disproved experimentally, and they don't like to let you know those experiments have been performed. And my one of my sons won the grand prize at the International Science Fair for showing that in his experiments. And you know, but it's very controversial. They say, well, that'll falsify all these theories, and we don't want it. And we want these theories because our reputation is built on it. Our grants are built on it. We want to keep it that way. We don't want to say, well, quantum mechanics is not true. And this happened in the case of the atom. NASA took data on hydrogen and helium atoms and showed that the quantum theory of the atom is false. And they even forced at the International Science Fair my son's project to be evaluated and granted the grand prize because they knew the data was valid. And but the regular scientific community didn't want that. And so you see this sort of thing going on all the time, particularly now that we are in the postmodern philosophy of science, where we have separate silos for each field, and whatever's discovered in chemistry doesn't apply to physics. Whatever's discovered in biology doesn't apply to physics or to chemistry. You know, they do all this sort of thing. They have separate silos, but in each field they falsify the theories in the other field, and using logic, or what we call common sense. And so that's the problem. What role do you allow logic to have? If you allow it to falsify these theories, then the experiments will falsify. But if you don't use logic, well, you can have all these varieties of theories, and they have a lot in common, but they're not identical, and they can be distinguished by using logic.
So Harry's got a question.
This discussion for me raises a number of issues. One is we come on here and Franklin proposes a topic and you start talking about it, but we don't really have any principles that we're talking about. We don't really have a philosophy of science that everybody agrees to. And I think that's, kind of an issue that needs to be addressed. And as Bill has pointed out, and I think rightly so, I'm wondering, what are the principles of mainstream science? I mean, has anybody seen anywhere where they say in physics, these are the principles of mainstream physics? I don't recall seeing any sort of book as that. I've seen, but anyway, that's kind of another topic. My issue is I don't really see why we need to talk about an ether. I really see no need for an ether. And to say that an ether has to be particulate, I don't understand why we need an ether in the first place. And in the second place, I don't know why it has to be particles. And until, you can establish some reasoning as to why, A, there has to be an ether, and B, the ether has to be particles, I think talking about the ether is just a waste of time.
Well, the word particle doesn't fit with ether. You would refer to quantum units, for example, as particle capacities.
Well, that's just meaningless. That's just meaningless words.
Well, I would say, as an etherist, your motivation is that you have effects that happen across space. So you have a radio transmitter at point A, you have a radio receiver at point B. Something happens at point A, which is received by point B. So it has to get from point A to point B somehow, okay? So the motivation for behind an ether is to provide a connection between points A and point B. So if you're doing like the tin can with the string.
So you're saying that points A and point B are disconnected?
Yes, point A and point B seemingly disconnected.
Now you have to provide proof that they're disconnected.
I think that would be intuitively obvious that they're disconnected.
How is it intuitively obvious?
There's no debate that we have something object at point A and 10 feet away we have object at point B. And
so now you're making an argument that they're separate and disconnected.
They're separate by disconnection. In the case of radio waves, we can produce a perfect vacuum between this transmitter and this receiver, and the radio wave is still able to go through that space.
Okay.
So the motivation behind
your fundamental assumption is that they're disconnected and separate. And so what you're trying to explain is why something that's disconnected and separate can be affected by each other, right?
Yeah, that would be the motivation behind the ether, to find that they're logically, in order for object A to affect object B, normally it has to run into it or something, or that's one way for it to happen. That if object A collides into object B, then it's obvious that there can be.
Well, okay, so now all I need is a particle that goes. So A and B are disconnected and separate, and so now I invent a particle that's a discrete finite object, and I send it from A to B. I don't need there to be any ether to have a particle go from A to B.
No, you don't. I mean, that is one possibility, that the way that A is affecting particle B is that particle A is shooting at particle B with other particles. That's certainly a possibility. So
that basically is a very old theory that's been around for thousands of years. And you can find it in the old Greek books on philosophy. But there's certain problems with that particular thesis. And but anyway, the point is, I don't really see why I need particles, and I don't see why I need an ether. Why do I need an ether?
You see the need to have an ether in order to put something between particle A and particle B. So if there
already is, that's called space.
But then how does space transmit those forces? I mean, you can say
Bill
that.
Bill just explained it. Were you listening when Bill explained it?
And he didn't explain. He said that the space itself, the electromagnetic field, is fundamental, is what he's saying.
Yeah, he just explained it. And you didn't even understand what he was saying, because you insist that you're thinking, you want to think about it your way. And so you automatically dismiss what Bill says is wrong because, that's
No, I understand what Bill said. Bill says the electromagnetic field is fundamental, but that's basically just giving another name to space. I mean, but the electromagnetic field doesn't describe...
Well, you just proved his case right there.
It does not explain mechanically how it transmits anything.
Space does it.
How does it do it?
Doesn't need to have an explanation.
Yes, it does. It totally needs to have an explanation.
That's basically your conceptual difficulty, not Bill's. Bill doesn't have any problem conceiving how it can be done. Do you, Bill?
Well, the measured properties of the field are that it has tensile strength.
And how can it have tensile strength?
Particles, regardless of the presence of any particles. And so that tensile strength is what allows forces between particles, and it allows.
So, Bill, that brings up this whole question of logic.
Pardon?
So it's logical to have tensile strength, which you would typically think of as like this paper has tensile strength because there are bonds between the atoms of carbon and whatnot in this paper. That's what we call tensile strength. But is it logical to say that you can have tensile strength in something which is not made out of particles? And I would say, no, that doesn't make logical sense.
Well, that's because you don't want to believe it.
No, it just doesn't make logical sense. In order to have
It doesn't make logical sense to you because you don't want to believe it.
No, it doesn't make logical sense because we know.
I don't know. It makes logical sense to me. I don't know why it doesn't make logical sense to you. So something must be wrong with your thought process.
Well, that's what we're here to debate. But
well,
in my
I think the bottom line is that it goes to my fundamental point, which is there are no ground rules, philosophical principles of doing science that everybody agrees to, and even mainstream, I don't think agrees to those principles because I don't know what they are. And so basically, all that means is that science is nothing more than decreeing what is true because the majority says it's so. And the majority are the people who are funded by the government.
You're never going to find any such explanation other than the one you just gave, which is that it's just basically a jury of your peers.
Why are we here wasting our time? We're not going to change the views of anybody in the mainstream physics.
Well, it's still our hobby and our duty and our desire to figure out what we believe what the truth is. Because if we think those mainstream guys are wrong,
yeah, but you won't accept anything that what Bill says, which makes perfect sense to me because you say it's not logical, but I think it's perfectly logical.
It's perfectly logical that there's a space, but you don't know what causes from something happened to point A, receives point B. You still cannot mechanically describe the basis of that transmission.
Well, that's because you're thinking in terms of a topology that says A is separate from B. And then your hypothesis of making A separate from B, then now you have to have some kind of assumption. Are they the same or are they different? Okay. Now tell me, what are they separated by, if anything?
Distance.
Space, right?
Distance.
Now, see, you want to argue with me by being semantical.
Well, it's all about semantics. What we have here is distance. Now, there may or may not be something between them.
Well, now you're totally confused.
Now, if you talk about space, you could be talking about a medium.
Well,
distance,
maybe not. That all depends.
Is that let's say a carbon atom is this big?
Your assertion was that A and B are different, and so therefore that there's a necessity to explain why something that happens at A affects B, on the basis of your assumption that A and B are different. And as far as I could see, I don't need any such assumption at all because you didn't really prove to me that A and B are different. You just assumed it.
Well, I would presume that is intuitively obvious that if I have
intuitively obvious is a meaningless statement.
Different, right? I shouldn't have to explain that these are different. That's a ridiculous argument. Right?
So how are they different? That's what you have to explain.
Well, one of them calculates and the other one makes noise. So they're clearly different, right?
How are they different?
They're made of different materials. You can see that they're different shapes. They are totally different, right? I don't know how to explain that these things are totally different when it's totally obvious that point A.
You just made the assumption that they're different. That's all.
No, that's not an assumption. That's absolutely true.
Well, you assumed it for the sake of arguing.
I mean,
you're just basically, making assumptions, and then when Bill makes his statement about what he thinks is happening, you say that's wrong and it's not logical because you made different assumptions about what is logical, and your assumptions about what is logical are different from Bill's assumptions about what is logical. So it's a pointless argument because your assumptions are different.
Okay, I want to hear from other people. So I have this noisemaker and I have this calculator, and Harry is saying that it's an assumption.
That's not what I'm saying at all, Franklin. What I'm saying is that your assumptions are different than other people's assumptions in this discussion. And until we get some kind of an agreement as to what the assumptions are and what the words that are being used mean, it's kind of pointless to just be we're just talking past each other. And I think what Bill is saying makes a lot of sense to me, and I think it's worth thinking about, and you just dismiss it. And, to me, I just think that's not right. But anyway, you can dismiss it if you want because you have a different set of assumptions. People who believe in the ether have a set of assumptions, okay, that they want.
Not about assumptions. It's not about assumptions.
It's all about assumptions. You're criticizing this theory of gravitation, because you didn't like his assumptions. Okay, you don't like the assumption that the Earth surface of the Earth is expanding at 9.8 meters per second. You don't like that, so you dismiss his theory as wrong.
I dismiss his theory as wrong because I think if you're going to make such an assumption, that there needs to be a justification or some experimental evidence.
All right, so what is your justification for the existence of an ether, and what's your justification for the existence of positive electrons?
The existence for an ether is, once again,
that's just an assumption on your part.
In mechanical sense, that point A, point B, when point A transmits to point B, it's going through a physical medium, which we can understand. It's a series of collisions. Point A gets to point B, so that we can physically, mechanically explain how signal can get from point A to point B. If there's an ether, that's trivial.
Well, I don't really see the need to have an ether. I think Bill's argument is much better and far superior to your argument.
Let's look at it a different way. We have these different silos in science. We have astronomy. We have regular physics.
Try and stick with the topic, Bill, though. Don't go into the big one.
Let me finish. In astronomy, what is the primary theory? The Big Bang theory. Where do the particles come from? Do they start as particles? No. The assumptions in astronomy silo are different from the assumptions in electrodynamics and elementary particle physics that we are using in our conversations here. And so who is right? And every one of these silos is different and has different assumptions. And so how does one do that? Well, in philosophy, we say there is no such thing as truth anymore because we cannot use the same form of logic in each of these silos. Each silo has its own type of logic it wants to do. And so they claim that we no longer have a university because since we don't use a common logic across all the silos, we never have any way of determining truth. And so that, I think, is the essence of what we're facing. How do we get back to a universal approach to things when we have a multiversity approach, which is a whole set of different assumptions in each silo, and they're true in that silo, but not in the other silos. And so I guess the question is, how can we overcome that? How
that isn't science, as Harry points out, that you never get that. You get as many different theories and many different assumptions as there are people.
Well, now their definition of science in each silo says, yes, our theory is correct. But you say in your silo, no, your theory is wrong, my theory is correct. But how?
And the only thing you can do is gather people around you who believe your theory, really, is all you can do. by just sheer argument and experimentation. It's a matter of, I can give my theory and you can give your theory, and people will gather around you and people will gather around me. I mean, and whoever has the most people and the most publishing power wins. And unfortunately, it isn't either of us. So, you have all these thousands of people in the university who represent that force, who control what they're teaching in the colleges and such. But, we're just here to kind of throw out different ideas. Like, if we think that the mainstream is not correct, then this merely serves as a forum for people to express what they think could possibly be right.
Well,
and to show the differences,
more
right?
than one mainstream. There's a mainstream for each of the silos of modern science. So
yeah, certainly there is. I mean, it's even hard to determine what
one another
that is.
And so that is a problem. I mean, we got, just like we don't necessarily agree with one another in these conversations, but in the formal politically correct science, each of the silos has its view, which is not compatible with the other views and in the other silos. So unfortunately, we're not making progress in science these days because of this approach. In the past, where we thought that logic would enable us to eliminate all the extraneous views and keep us in one silo, that got overcome politically, and now I think we're, some people say that no major significant progress has been made in science in the last 50 years because of this.
Well, that's the whole question about what logic is. I mean, I could say that some of the things that anyone says is not logical, but, Harry might be right in saying that, well, that's just your opinion, because all of these, and it might be. So, I mean, I might try and point out logical problems in your theory. You might try and point out logical problems in my theory. But still, it's all words. So,
Well, mine is based on mathematics. In other words, I do experiments, and I reduce the experiments to empirical laws. And then on the basis of logic applied to those laws, I build the theory. And so that's one approach. Now, if you work in terms of the experiments and the empirical laws that explain the experiments, and then you combine all that together logically to come up to something more universal, that is something that you could use logic to falsify various approaches when you didn't do it consistently. And,
well, here is one problem with logic. So let's take this concept. So Michael is talking about fundamental ether particle, and dissidents will often basically describe it that way. And James Carter thinks everything's made out of circulons. But and once you do that, once you create your particle, then you can go ahead and build out this entire world out of that thing. Although
it's not a particle in my model. It's just a unit. It's massless.
Yeah. Okay. It's a fundamental something, and that it may not be that, but you're starting out with something that is basically not been experimentally found yet.
No, that's not true. That's not true.
Never been found.
Empirical laws of electrodynamics and solve them simultaneously, which we don't do today. We only take 4 of the 6. If you take all 6 and solve them simultaneously, you find out that all elementary particles have to be compressed or composed of these toroidal rings of the field, what we call solitons. That comes right out of the equations. Now, and I claim I'm using logic on the equation, but you or other people would say, well, I don't like that logic. But how do you falsify the logic? You have to falsify all logic if you don't use logic.
Well, I think Lori showed quite clearly, like in her last presentation, when people start playing around with E equals HF and E equals MC squared, and you start equating those things, it's very hard to tell logically that you can't do that.
Well,
and when you go and you start equating all the laws of electrodynamics
together,
I'm not sure you can do that either. I think you're probably equating apples and oranges again. And if you conclude that everything has to be a toroidal ring, then we're taking a lot of leaps there.
No, we're taking the accumulated results of electrodynamic experiments, which have been codified in terms of 6 equations, and we're just solving them simultaneously. That's all we're doing.
Yeah, like I said, there's a lot of danger in solving simultaneous equations. A lot of these, if you put one equation on one side, another thing on the other side, just because what appears to be in the middle, like in the case of E equals HF or equals MC squared, or
solve differential
1/2 MV squared, and you just start equating those things.
Never taken a course in calculus and solve differential equations.
You can solve equations all you want, but if you start with the wrong things equated together, you can very easily.
We're starting with are all experimental, no opinions.
Well, the thing is that all of those things are experimental, like E equals MC squared is experimental. E equals HF is experimental.
Electrodynamics. And
What's
electrodynamics
bad is when you equate those two things together and solve simultaneously.
Electrodynamics defines what mass is. E equal MC squared doesn't tell you what mass is.
Well, the point here is that I am basically attacking the logic of it, basically taking these empirical results and then trying to equate them to each other when they may in fact be talking about entirely unrelatable things. So if you start equating equations that concern the electrostatic field with equations that have to do with the magnetic field, I would say you are in very, very risky territory.
Except that they all have a consistent solution. They all, when you solve all 6 together, you get a self-consistent solution. Does your solution or anyone else's solution make a self-consistent description of the universe with no irregularities?
Well, I would say that is not really a requirement. I mean, we know that these equations come from the result of empirical experiments. What your theory has to do is it has to explain where the motivation, the mechanical basis of those equations are.
But you see, my theory I don't contribute anything to my theory. All I do is show how to do the solution to the equations, which represent the empirical data. I have no assumptions made like you have and other people. The assumptions are built into those equations. And they come from
the equations themselves also don't explain the phenomenon itself either.
Yeah, they explain all the phenomena we've ever tried to explain.
No, it explains
How do you explain the quantization of gravity?
First, you'd have to show that gravity is quantized.
It has already been shown for hundreds of years. Bode did it, and now more recently it has been done so that you can explain the orbits of all the planets around the sun and of the planets of the moons around the planets in our solar system, and and you get it fairly accurately. So not take into account any problems with meteors and all kinds of things that come in from outer space into our solar system and disturb it.
Well, that is once again an empirical observation. But having the empirical observations doesn't motivate as to why exactly it does that.
But if your simultaneous solution to the 6 empirical equations of electrodynamics does explain that, what else do you have to do?
Well, I've looked at your stuff, and I still fail to see the connection. I see some pictures, I see some equations. I don't see the connection between Bode's law and those equations. Honestly, I just don't. It's like you're saying they do, but you're just saying it. It's not. I don't see anywhere that actually takes that equation and then in a sensible way results in Bode's law. I still haven't seen that in any of your materials.
That's not the Bode, the older version of Bode's law, which is just numerical. It's the one that is in quantum type form, period of the
but still, I haven't seen it, and furthermore, I haven't really heard an intuitive explanation as to, you should have a more intuitive explanation as to motivation for why the position of Venus and Mars and Jupiter and Pluto should be in this approximate, twice as far as the previous one. The actual expression of Bode's law in a non-precise form is not that complicated, but it seems that, I'm just telling you from my opinion, and, I've read your work and I'm very familiar with it. It's still not, it's
the electromagnetic field
connection
to the 39th power as strong as the gravitational field. And it's the only field that we see everywhere. And but like we no longer see the strong interaction field and the weak interaction field because the data no longer supports it. And
yeah, we both totally agree on that. Strong force, weak force don't exist.
Being able to derive the force of gravity from electrodynamics. So but in order to do the solar system, you got to take into account the stronger electric field in addition to the weaker secondary effect we call the force of gravitation. And so, yeah, I agree with you to some extent that I haven't finished the publication of that. I'm still working on it for the newsletter for this year, actually, for Common Sense Science. So the we have right now is crude, but it shows that it's there. That's what we.
But getting back to Harry's point about why on earth someone should have an ether, because Harry is perfectly satisfied with your explanation that the electromagnetic field is fundamental. So everything the electromagnetic field does, which is like attract protons and electrons and whatnot, is fundamental, and you don't basically have to explain that.
Well, I'm not exactly saying that. So, but my view is a bit different from the way you're summarizing it. But you can go on if you want.
But I'm going to contrast my point of view, which is I feel that that's not satisfying. To me,
why?
Because to me, I want to know if I put a proton and electron together and that they spontaneously will come attract each other, I feel that there must be some mechanical action behind it, because that's just the way my mind works. I always think of things.
So you're saying that there has to be, you're making the assumption that the world has to be mechanical.
Yes, that's definitely how I see the world. I see the world, I think you got to be able to explain it on a billiard table. But that is my personal bias.
That's the problem. The problem is that, throughout history, if you read my history of magnetism, they tried to explain that the ancient Greeks and now in recent mainstream physics have tried to explain things mechanically through this particle theory, that particles are what causes the interaction that affects the actions of fields. And, why do you need that?
Well, that you just clearly pointed out that that's what people want to do, because they want to have a mechanical explanation.
Right. So you're saying, but there's no justification for why you have to have a mechanical explanation.
Because if it's a mechanical explanation, then we can see it with our eyes. We can see that
is refuted by the fact that
particle B.
All the attempts to make a mechanical theory of the electromagnetic interaction have not been successful. So, the problem is, you want to make it mechanical, but the experiments don't confirm that attempt at making it mechanical. So, why are you insisting on making it mechanical when it's not?
Well, I don't believe there are any experiments like what?
Well, there are no experiments. For instance, in the old days, they thought that particles, that the magnetic attraction was caused by particles flowing from, let's say, for instance, a magnet attracted iron or steel. Now, steel didn't exist in those days, so iron. And so they said, well, particles flow from the magnet and reach out and they grab the iron and they pull the iron into the magnet. Well, so then somebody inserts a steel plate or actually they didn't use steel plates, a silver plate, and they found out that the magnetic action went through the silver plate. Okay, so how can the particles flow through the silver plate to cause this action? And they couldn't explain that, so they decided, well, maybe particles wasn't what really is going on.
That hardly sounds exhaustive.
Yeah, it hardly sounds exhaustive. That's kind of like one edge case.
Well, it wouldn't convince me if I was watching the experiment.
I mean, I don't think that magnetic field has anything to do with particles myself either. I mean, basically, that's an electrostatic effect, magnetism, ultimately.
I'm just describing the historical process, okay? So, you know, now it's back to the drawing board. How do we explain, since there's no particles or effluvium that is emitted by the magnet that is supposedly grabbing the iron and pulling it to the magnet, because we can block this flow of these particles by putting an object, you know, that blocks the flow, but it doesn't block the flow. So how do we explain that?
Didn't we also?
You have this problem of you know, the mechanical action doesn't explain it.
We used to believe.
You find the mechanical action that does explain it.
Well,
I
submit that's illogical because that's contrary to the experiment.
No, the experiment was testing the hypothesis that there was some particle going between the magnet and the iron. And that experiment disproved that hypothesis. So that hypothesis is clearly wrong. But it doesn't disprove the idea, the ether idea, that there is some material. You know, if you talk to different people, it would do different things. Or if you talk to Bill, you would say it is the thing. But for me, I see the problem with this like the circulon or the fundamental ether unit is that it is basically a made-up particle. I would oftentimes compare that to take whatever you've got, you know, so call it the fundamental particle and just rename it Little Green Fairy, which you can. And then once you do so, you can quite easily tell why is it no one is paying attention to your theory, because when they hear the name of your fundamental particle, you know, call it FP, they're substituting Little Green Fairy. And you just can't start theories on the basis of Little Green Fairies. I mean, you're building a castle in the sky. So that was my response basically to John Roach on this, is that and he favors, say, the circulon as the unit of ether, and circulons make up are somehow waves, and waves make up matter. And that's kind of how he goes. Now, mechanically, I think that fails in a lot of ways. So I think that the main problem with the ether is that no one's been able to actually identify that sucker, okay? So it's kind of hard to say, I believe
it doesn't exist.
What the heck it is.
I mean, I don't really see why you think it should exist.
Well, once again, I think it should exist so that forces A can be transmitted to distant point
Okay,
B.
so let's go to
something in there that does that transmission.
So we're doing science. So supposedly, if you're doing science, you're based on some kind of empirical fact. So there's no empirical facts that show that an ether exists, and you want to insist that it exists and call that science.
No, there are empirical evidences that the ether exists. In particular,
What are
that
they?
there's a sea of positrons and electrons. The Lamb shift clearly
What are
says
they?
there must be a field of charged particles in space. If we have pair production, which demonstrates that positrons and electrons must exist in space.
What does that got to do with ether? I don't see that proves anything.
We've got a lot of empirical evidence that there is something.
Orbital velocity of galactic arms.
What about the orbital velocity of galactic arms?
They forced us to give up on relativity and conjure up dark matter, dark energy, which, what are they if not an ether?
Well, I think that, I mean, in some ways the mainstream has kind of totally recognized the ether, but it's called things like quantum foam,
Quantum
matter.
strings.
So in other words, you can
Strings.
deduce any kind of discrepancy in science and call that ether.
That's not
Well,
what we
the
did.
problem is that we haven't definitively, identified it with an experiment. All right.
Well, what Bill is saying in effect basically is that he's got empirical facts that support the idea that he is proposing. And on the other hand, you have this theory of Roach and Carter that seems to be not based on any real facts. It just creates out of fantasy or something that he imagined. He's imagined this ether particle, which you object to and say it's not reasonable and it's not. So you object to the particle of this ether particle. So he's invented this particle based on no empirical facts and says, okay, he's going to build a theory out of that. I think that's not science, and that's what we should be avoiding.
Well, I would agree with you. I mean, that's my main problem with just kind of inventing this ether particle.
Yeah, but that's what your theory is, Franklin. That's my point.
Not my theory. See, my theory is different.
Right. Okay.
Because I start with particles which we know exist, which are electrons and positrons. Now, you can as a theorist, you can go and base your theory around, like I said, you can base them around circulons, as in James Carter, or fundamental particles, or whatever. But none of those things have ever been found or recognized by mainstream. So if
you're just doing the same thing, but you're just saying,
I am basing everything off of
because I'm using positrons and electrons, which can't go together. But
and we know those exist, man.
As a positive electron and say that exists because I say so. Can you call that science?
Well, the thing is that what is science is that I have to, do exactly that and call it a positive electron. What I need is someone to invent a very convincing experiment to show that's either true or false. So that's how.
Okay, so your theory stands on the lack of experiment.
Yes, it stands on the lack of experiments. I mean, that's one proposal.
So that's
it's a hypothesis.
Not really science. I mean, we can.
That's what we have when we have a hypothesis. Theoretical physicists like me come up with the crazy ideas, and they may be crazy, but if they make predictions.
But this isn't science, Franklin. That's the whole point. I mean, it's not science, and talking about it is just kind of a waste of time to a certain extent. Okay?
No, that is science. I mean, suppose like tomorrow the University of Washington announces, oh yes, we've made a major breakthrough. We've discovered the existence of a positron electron C, and this is the experiment we have performed to show that it exists everywhere. It's omnipresent.
I don't know why we're discussing hypothetical non-existence.
Because
this is just an hypothesis on your part that you want to throw out for the sake of discussion. It's not science. Okay.
No, that is science. Science is throwing out hypotheses and then having people confirm.
Well, at this stage of the game, we should be working on some empirical facts. Okay, so the real question is
some empirical facts. So
the real question is, if we're talking about this theory that has been proposed by Carter and Roach, the real question is, what empirical facts form the basis of their theory? What are the empirical facts?
Well, that would be difficult because you'd have to be able to prove the existence of the circulon, right? Which is this spiral.
There's no empirical facts behind his theory, and so it's not science.
Well, I mean, they're empirical facts. His structure of his atoms is consistent with the observed empirical facts. That's one thing.
The real point is basically you can construct a lot of fantasies out of the that's really what it boils down to. I mean, you can construct a lot of fantastic ideas and claim that they're supported by empirical facts. Okay, that's where the problem lies in science, in that scientists, they invent dark matter. They say, oh, well, we can't explain the spiral arms, the rotation velocities of spiral arms. So therefore, we hypothesize the existence of dark matter. Okay, to them, that's science. To me, that's just kind of like making up stuff.
Well, I mean, that is, but this is how science kind of works, at least in my mind, is that you have various crazy theories thrown out by different people. So like I say the atom looks like this, and James Carter says the atom looks like that. Okay, so there's two completely incompatible hypotheses, right? Now, someone might be able to come up with some like scattering, I don't know, experiment or something, whereas if they scatter against something like James Carter, where his atoms are completely flat, versus a cubic atomic model where it looks like an octahedral, they might be able to say that this experiment is more consistent with like this or that. I mean, that's how they figured out like what the form of the DNA helix is, right? So I just saw a NOVA on this or something, and they didn't know what the DNA helix looked like. And Linus Pauling, he came up with like this proposed a helix that had like 3 ladders on it, and then they finally came up with the one which is 2, based on basically X-ray crystallography. See, so they're able to see something where they had 2 different possibilities, but because the experiment was more consistent with the double helix, that became much more convincing. I mean, I'm not sure that even today we have imaged the DNA molecule down to the point where we can actually physically see the double helix. I don't know, maybe we have, but that was an example of having various hypotheses which are confirmed by empirical experiment. So it's not hopeless. And that this is the reason why we think that the DNA helix is the way it is, because it is consistent with experiments. And now we can do things like sequence DNA, and then we can do all kinds of useful things based upon that work, right? So it's not as hopeless as dark energy or matter or whatnot. I think it's still solvable. And questions about the ether, I think, could still be concluded, but you need to have an ether that's actually experimentable, right? If you think it's some unit that can never be detected, then that's a problem, because no one will ever be able to confirm that.
I see no need to have an ether. I mean, I don't really see a need for it. I think Bill's approach has essentially eliminated any need for an ether. And
well, except that
talking about ether particles and talking about an ether, to me, seems just not be science at all. It's not needed. It's not necessary. It's just speculation without any basis in fact.
Well, I think it's totally needed, because even Bill's field, I mean, if you think of what fields are, like fields of corn or magnetic fields or electric fields, they put different characteristics in space, right? Space which has magnetic field is different than space which does not have magnetic field. Now, the thing is that there must be something there that's holding those properties. And to me, the only thing that can hold those properties is matter. So if it's matter, then it is a field of matter that's holding those properties. Or you could think it's a field of something else, not matter, but still able to hold those properties. But I find that incomplete or illogical. So even if you think that there is this electromagnetic field, I would contend that logically there still must be matter backing that thing up. If you think there's matter backing that thing up, then we're once again back to a mechanical ether. So, Michael Antesky, you've got a comment?
Well, just to defend your basic premise about the ether, that it's a medium, there has to be a medium there. That was always assumed by all the classical physicists, including Isaac Newton, up until 1888, when the Michelson-Morley experiment was done. But in 1888, they made certain assumptions about what the nature of an ether had to be, and they assumed that it would be acting purely as a medium. And then they did optical experiments in which the velocity of the Earth, the rotational velocity of the Earth, was compared with light passing through optical refraction instruments, and they ruled out an ether, and that's how physics went from then on. And Einstein came up with curvature of space and so on. And but in defense of Franklin's basic premise on propagation of through an ether, it was a classical concept that was assumed by everyone firmly until Michelson and Morley. But in my model of the ether, it wouldn't be just a medium. It would also have electrical properties, a vibrational, resonational property, which would have thrown off the assumptions of the Michelson and Morley in 1888, but they didn't ever took that into consideration. But physics has stuck with that ever since.
Okay, so it's interesting that you bring up Michelson and Morley. So getting back to John Roach's letter, so he did mention that. So, but he has something that he calls neodynamics, I think here. And basically, I still had a hard time trying to figure out exactly what he was saying about that. But it's more getting back to kind of an Earth-centered type of gravity. He goes in his paper. He has several things about the retrograde motion of planets and things like that. But ultimately, he seems to come to this kind of hypothesis where the Ptolemy Earth-centered universe seems to come in existence. So, but I told him to say, my observations about that is that if you just look at the experiments, it seems that the Earth appears to be spinning around some motionless point in space, because that's basically how the GPS satellites see Earth when they're zipping around. So, you know, if you think about these GPS satellites, you know, they're like a whole constellation of these things in every possible orbit, going every possible direction. And in order to make precise calculations about where I'm sitting on the Earth, they have to take into account the actual motion of the satellite. And because if you're sending a radio wave and your receiver is moving, it will receive it sooner than it would receive it if it were not moving. So you can understand that, right? So it would intercept the signal sooner, and in the scale of GPS, that makes a pretty big difference. But when you make those kinds of assumptions, you kind of basically have to presume that the Earth is spinning, its surface is spinning around a stationary point, which is called the Earth-centered frame. So that is basically what the experiments are telling us about how the Earth is moving. So in that way, that kind of seems, you know, geocentric, right? That somehow the center of the Earth is special. And there's been some other notes in the chat saying, well, the way we could tell this is by sending out satellites with MMX experiments on it, and then we would be able to really see what the speed of space is, right? And I agree with that. I mean, we should do that and find out whether the speed of what we think is a fluid, because once again, this is all getting back to assuming that there is some material ether. That you should be able to, that affects the speed of light, you should be able to observe what is going on. Now, my personal feeling about that is I think we probably observe this because the ether is most likely entrained upon the planet, much like the atmosphere is entrained upon the planet. And there have been more sophisticated experiments than, let's say, Dayton Miller, who did measure significant seasonal changes accelerations about the Earth. So, and if you would have asked Dayton Miller, he would have said, yeah, we can measure the velocity of Earth, but it's much lower, just much lower than you would expect. Or it could be just like we have weather on the Earth and we have seasonal weather that gets, the wind generally goes from, the west to the east, something like that, that there may be an ether wind, and maybe that's what they're measuring. But the real proof in the pudding would be to send a satellite out and see whether you're, past the orbits, it's somewhere in the middle of the solar system, whether you still have to make your calculations relative to Earth being in this stationary point, So if you're past the orbit of Mars and you still have to make your calculations as if Earth were stationary.
My question at this point is, Franklin, what makes you think that if mainstream did such an experiment, that they would reach to the conclusion that you would agree with?
Well, it would just be a matter of the veracity of the argument and the.
Well, basically, the way I view it is that if I'm an astrophysicist at Goddard or works at NASA Goddard, I'm going to process the data based on my set of assumptions, and I'm going to make the data work out to prove the assumptions that I assume that I want to have the data prove. And while mainstream says they don't do that, that's what they do.
Well,
so my question would be, what makes you think that such an experiment can be done?
Well, it's easy enough to do the experiment if you got the money.
Yeah, it's just a matter of convincing someone. Although, actually, I think probably the evidence is probably already out there, because I'm sure they've putting variometers out on some spaceship.
It might be out there, but how would you find it? Because they processed all of the experiments to confirm their preconceived notions about the world is like, which kind of goes to what Bill is talking about, the silo. These people have built a silo, okay, and they've created a set of computer programs based on their assumptions and their ways of thinking, and they're going to interpret everything in terms of that particular thought model. So why would you think that they would interpret an experiment that would confirm your theory?
Well, I don't think that's true. I mean, that's the whole origin of dark matter, and that there is completely a experimental result that did not fit at all into their existing framework, but instead of proposing some other framework, since they couldn't, and this is a case where they couldn't fudge the existing theory to work. They just couldn't. So instead of doing that, they just threw up their hands and invented something called dark matter. So in that way, there is some hope that...
Well, actually, they didn't invent it. That's not really true. What they did was they said, well, we can explain the empirical facts by assuming that there's missing mass that we can't observe. So in other words, it's mass that they can't observe, and because it's not observable, it's therefore missing mass. And then that missing mass evolved into dark matter, okay? And it's really, dark matter is really incorrect. What they're really talking about is missing mass. So all they did was add in the mass that should have been there that was missing because they couldn't observe it when they, so you understand this. What they would do is they measure the luminosity of the galaxy, okay, and then they have like a coefficient that tells them that so much light coming from this galaxy equates into so much stellar mass. Okay, so then they estimate the stellar mass based on the measured luminosity, and it turns out that the amount of stellar mass based on luminosity doesn't equal the amount of mass that they need in order to get the gravitational equations to work correctly. And so they said, well, there's dark matter there, okay, that is unaccounted for because it's not luminous mass that we can measure. Do you understand that?
Well, my only point was that when
we're talking about this issue now. Okay,
The
so
issue is that
the
when
point
science
is,
runs
the point
experiments
is
that they
that
can't
from their
explain,
point of view, it's
they're willing to admit
perfectly
it.
logical that maybe there's stars there that aren't shining as brightly as they assumed in their luminosity measurement. That's where this dark matter missing mass comes from.
Well, it's still on. I think it's still a very open debate as to what this stuff is. Although lots of people have made money in dark matter searches, which have come up with nothing so far.
Well, what they did was then they morphed this missing mass, which wasn't there. I mean, when they measure the light coming from a galaxy and they say, okay, this amount of light that we measure equates to so many stars, and the average mass of a star is X. Let me explain it. And so therefore,
already. We don't need to hear it again.
Well, okay, the point is it's not exactly, it's sort of morphed from being something that made sense into missing mass, which is something that doesn't make sense. Okay, do you understand that at all?
Well, here's another experiment that when they look at the CMBR, you know, it appears that the Earth appears to be specially centered within the CMBR. They call that the axis of evil, which is another example of experimental result which completely contradicts existing mainstream, but yet we still hear about it. It's not like they managed to shoehorn that into something. It's
well, as Bill pointed out, the astronomy assumption is the Big Bang, and that's their silo, and they have to explain everything on the basis of the fundamental assumption that they started with. And so once you start building all these, you know, deductions based on a fundamental assumption, and you can't declare your fundamental assumption faulty because that negates your whole science.
Well, once again, I'm showing you a counterexample of that because, you know, this.
Why do you need to show me a counterexample?
This example has come out that they can't explain why it looks like the Earth, you know, the plane of the Earth, the plane of the galaxy appears to be aligned with the CMBR in some special way, very closely. They can't. That totally contradicts any kind of Big Bang theory, not unless you think, I don't know, the Earth was the center of the Big Bang or something like that. But yet that result gets out there. You know, the other result that's hard to explain is that when they look at the distribution of galaxies, and it looks like there's these walls of galaxies that just seem to perfectly center around the Earth, they can't explain that either. So, but yet they recognize that. I mean, you can go search for these things, and that
well, that just goes to what I'm saying, which is they work really hard so that their fundamental assumptions don't get negated or falsified. So they can maintain the silo, and they can maintain the funding, and they can keep the textbooks and not have to radically admit that the textbooks are wrong.
Yeah, but my counterpoint to that is that there are examples.
Why do you need a counterpoint? What's the point of having a counterpoint?
That you're not right. That it's like those contradictory results do come out, and they may shrug their shoulders at them, but
that doesn't necessarily mean they're going to interpret them in a way that refutes their assumptions or their fundamental paradigm.
Yeah, that's right. They don't. They usually just shrug their shoulders and say, "Yeah, okay."
The question is, why? You know, what makes you think that there can be an experiment that suddenly is going to prove your theory? You know, you're going to do an experiment, and your theory will be proved. I don't really see how that follows.
Something that you can't experiment on. I mean, we know what positrons are. We know what electrons are. We know what their properties are. We can see them in our experiments. If there's a sea of those things out there, then that should be certainly something that you should be able to actually prove or disprove.
Well, if I'm a mainstream scientist, I would say that your hypothesis is absurd to begin with, and I don't really need to waste my money on a hypothesis that I already know is wrong.
Yes, that would be a main thing. That certainly is.
And the main problem with your hypothesis is that we know that positrons and electrons, when they meet each other, annihilate each other, and so therefore there can be no such thing as a pos-electron.
Yes, and I would have to overcome that. I would have to logically explain that we think that logically matter is things that are ponderable, like my finger, and things like my finger just don't disappear. And that the only logical explanation for annihilation is that the positron and the electron have just joined together to form a very difficult to see neutral particle, and that is what's there. That makes more logical sense than to say that that matter was destroyed, since we generally believe in conservation of matter, except in every case other than annihilation somehow. We make an exception, but I'm saying we should not make an exception. Logically, we want to maintain the fact that matter cannot be destroyed, and matter is conserved always, and not make any exceptions, and explain that what we were looking for is that combined positron-electron C is what we're looking for. Rather
well, why
than,
should I look for it? I know it can't exist, because all of the experiments that have already been done show that it doesn't exist, and there are none that support this thesis, and so I see no point in doing any experiment to test your theory whatsoever.
Well,
why should I waste my money doing that?
Paraproduction certainly supports the idea that there are charges, a sea of charges, already existent in what appears to be empty space. That certainly is also logically supported, that we think that things just don't appear out of nowhere, right? Especially matter. So if an electron just suddenly appears out of somewhere, it is a more logical presumption to presume that it was already hidden in the background C rather than to think it was created. So that is also evidence. Like I said, also the Lamb shift, they call these things virtual particles. I mean, it's pretty much recognized that there is this sea of particles out there, but they call them virtual particles. And that they say these things wink in and out of existence.
Okay, well, I have a question. Bill Lucas, what do you think about this? You're a physicist. You've actually done physics experiments. What do you think about Franklin's theory?
Well, in my approach, the idea is you must have logical consistency. So, for instance, we were just talking about dark matter. When I derived the force.
Well, Harry's asking you specifically about the possibility that space is a positron-electron C, or a charge of C's, or something like that.
Wait a second. Let me give you the example here. When I derived the gravitational force from electrodynamics, I got something.
I hate to interrupt you, but you're not answering the question that Harry is asking, and I want to know what the answer is as well.
Okay, but I'm giving an answer in a couple different ways. Hold on. I was able to derive the force of gravity and get a definition of mass, because I got the force of gravity and force of inertia. When I applied that to our solar system and to the spiral galaxies, I was able to predict with no dark matter and no dark energy, just using the electrodynamic version of gravity, I was able to predict precisely with no adjustable constants exactly what is observed. You don't need dark matter or dark energy. So that is a confirmation, it seems, that your approach might be correct. So in that same electrodynamic approach, now you find that there's no longer the concept of particles that we've been using for a long time. The concept is that all the particles, all elementary particles, are made of different combinations of solitons. And so you write down formulas for that based on the symmetry of electrodynamic force, and from that you're able to predict the mass and the decay properties and other properties of all the elementary particles using only the empirical equations of electrodynamics, with no additional assumptions. And so that seems to be a type of confirmation. And the wider the confirmation, the broader the confirmation, the better you can say the theory of electrodynamics is. But that's not my theory of electrodynamics. That is the result of the experiments that were done that were basically summarized by these empirical laws, these 6 laws: Ampere's law, Faraday's law, Gauss's law, Lenz's law, and Lorenz's law. So those laws, which we still confirm in the laboratory experimentally, and if you find a new experiment that doesn't agree with them, you correct the law, and then we just use that as our solution, and we get an improved version of all these theories when we do that. And that's what we need to be able to do with any approach that we have, but we don't take that overall view. We separate everything up into silos. So the theory,
I'm not sure we're ever getting around to answering Harry's question as to
go ahead, ask.
Empirical evidence for there being space being filled with charges or something like that. I don't think you've answered that question at all.
If you look at the cosmic background radiation, which, by the way, I did the experiments that caused the 2 people at Princeton to receive the Nobel Prize for cosmic background radiation, but my experiments were more complete, but I was an undergraduate in physics, and they're not allowed to receive a Nobel Prize. So these other guys knew that. They just did the experiment and got it. But anyway, in that work that I did, you find that cosmic background radiation occurs with a density where the density of matter is. If we had a ether of positive electrons, we would have a certain density throughout the universe of cosmic background radiation and a certain polarization. We don't see that.
Well, I think though one of the contradiction unsolved questions in physics is that when they try and come up with like the energy density of space, it comes out to be some absurdly ridiculous value. I'm not exactly sure if I understand what they're talking about there, but it might be consistent with the idea that it's just considered it is filled with an incredibly dense matter seed. So we're getting towards the end here. I see Jim has raised his flag. So Jim, you had a closing comment?
Yeah, I think as I've been trying to point out here is that the empirical evidence about ether being destroyed by the MMX is actually because it hasn't been, all the repetitions have not been sensitive enough to detect the Earth's rotation as the speed to look for. So that's the key.
Dayton Miller did that, but they basically kind of ignored or discredited his results after he died, for example, when he wasn't able to defend them. But during his lifetime, he completely defended his results of an improved MMX, which did show.
Even his experiment wasn't sensitive enough to find the Earth's rotational velocity.
No, actually it was. He would have claimed, yeah, it's rotating.
He claimed to find a velocity that was with respect to a global ether, a universal ether as well.
No, actually he did. I mean, he said that we are heading in, a certain velocity towards the constellation Drago or something like that. That's what his
velocity. I'm saying the velocity is that the Earth's ether is entrained out to about 1 million kilometers, not infinitely, as you seem to think that it would.
No, I don't think so. I think it's probably entrained. 1 million miles might be fine.
Fine. So even the modern repetitions have not been sensitive enough to find that, except the Broglie Hall experiment, and they discarded the data because it was so buried in the noise that they considered it to be a spurious effect. But that's the whole problem. We know from first order experiments, or first order measurements, like the GPS pseudo-range correction, also called the Sagnac effect, the Michelson-Gale experiments, and even what they call intercontinental microwave relay experiments, that the Earth's rotational velocity is the velocity to look for with an MMX type experiment. And to refute Harry there, the fact that that a low Earth orbit experiment would find a result would be a direct contradiction to all the experiments that claim there is no ether. So they couldn't ignore it.
Well, I don't claim there is no, quote, ether. I claim there is no ether made out of particles or any material substance.
Yeah, but if you just have a mathematical point that has a value, how does that transmit forces? Space has all these mathematical.
Already, well, why do I need to construct an ether out of particles that nobody can prove whether or not they exist?
Well, first you got to explain. First, you got to prove that there probably is an ether. And then you can talk about what it's made out of.
That's putting the cart before the horse. That's not science.
No, it's not. Putting the cart before the horse is trying to explain exactly what it's made of and its detailed properties. First, you've got to say, well, we do have evidence that there's an ether.
But there isn't any. So you have to. There isn't any evidence that there is any kind of material, particle, ether that transmits gravity or electromagnetic radiation in any way.
Well, you have to be able to explain the measurable properties of empty space. You know, empty space has a specific resistance, it has specific permeability, it has a specific permittivity, and these are things that are also properties of material substances, right? So permittivity is a property of a material substance, and we can measure different dyes.
There's no material substance out there, so what do I have to assume that it exists?
Space, and we find it also has a value, which is not zero or not immeasurable. So that in itself would indicate that if space has the properties of material substances, that it too must be material.
But the material
you couldn't measure a property.
The only reason that ether was thrown out is the
particle properties from the ether. The ether is not particulate, but the particles are made of geometries of energy within the ether. There's no evidence that ether is particulate, and there's no way you can explain the connection between particles unless you have additional ether between particles. But if you have the particles become a basically geometry of energy within the ether, then you have a full continuous explanation.
Franklin?
Yes?
Do we have a topic of conversation for next week?
Yes, Jeff Yee is going to be presenting next week on January 12th.
Okay.
So don't miss that.
Can we schedule me in for whatever week is open after that?
Sure, if you would like. It's like, I think, probably the 19th through the 26th. Just send me an email.
Okay, we'll do. The topic of discussion will be a repeat of what I talked about last year, only I know more now and can speak a little better to it now. And it is a particle-based physical mechanical ether theory.
Okay, great. Just send me an abstract and we'll get you scheduled.
Will do. Thank you.
Okay, but I think that pretty much does it for this week's episode. I mean, I did get just a nice quote from John Roach, which is that theoretical scientists have two choices: dig deeper, which means, dig deeper into your wrong theory, or sell life insurance door to door. So that was a funny quote. And he did also say some things about, Einstein, although I think Einstein is just grossly misinterpreted. There have been some things in the email chain about the mistranslation of Einstein's work from German, but I think that people are just so desperate to interpret it to mean that light travels at the same speed in any frame. That's what they want to interpret it to be, because that is the mainstream interpretation. But that is so completely oppositely wrong of what he meant, which is that the speed of light is constant with respect to the stationary or special frame of the laboratory that's doing the experiment. That's what he actually said. But that was another topic of conversation we didn't get to here in this letter. But I think otherwise we got to a lot of what he was writing to me about. So once again, that was an interesting letter. I thank John for writing that, and I don't think he should be discouraged if I disagree with some of the things that he's trying to say. You know, like I very much disagree with the gravity model of Earth expanding, and that there's an ether particle made out of circulons. You know, but that's what we do. As it was pointed out in the philosophy of science, we really don't have any set rules. It's just a bunch of kids arguing in the playground, and a matter of who can get more people around them is kind of the winner. But even you can continue to believe whatever you want, and which is what a lot of us dissident scientists do, and what a lot of science does. I mean, once something gets embedded into science, it's extremely difficult to remove it. Some people don't believe in continental drift, up until the time they died, and it's like they never will. And so there's no resorting to retreating to an absolute logic, because once again, logic is about opinions and assumptions and about what's important to you. But here at the CNPS, we encourage all viewpoints, and we're not going to tell you you're crazy, even if you are. So, but it's all about the debate, which is what science chatted about. So, thank you for participating. And like I said, next week will be Jeff Yee. He will have a presentation for us, and I'm sure that'll be very interesting. So don't miss that. But for now, that will do it. So let's sign out here.
Thank you, Franklin.